Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on hyperbolas. In this unit, you have studied many different kinds of conic sections, such as circles, parabolas, and ellipses. Today, we look at the last conic section, the hyperbola. Are you ready, students? Let us begin. A hyperbola is formed when a vertical plane slices through a pair of cones. One simple way to think of a hyperbola is to imagine that two parabolas, opposite in direction, are put on one axis of symmetry. In order to form a mathematical definition of a hyperbola, let us begin by learning some terminologies. In this diagram, F and F prime are two fixed points called foci. Midway between the foci is the center of the hyperbola C. The points V and V prime are vertices found at the point on the hyperbola closest to C. The line drawn from V to V prime through C is called the transverse axis. A small a denotes the distance from C to V and C to V prime. A line drawn from the center to either of the foci is denoted by a small c. A line segment perpendicular to the transverse axis at the center is called the conjugate axis. The endpoints of the conjugate axis are co-vertices B and B prime. A small b denotes the distance from C to B and C to B prime. As in the ellipse, a relationship exists between A, B, and C. The length of B equals the square root of C squared minus A squared. A hyperbola is defined as the locus of points in the plane, such that the difference between the distances from any point P at xy to the foci is a constant. Let us say that we have 2 points P and Q. If the distance from P to F prime minus P to F is equal to the distance from Q to F prime minus Q to F, then these points lie on a hyperbola. A hyperbola can have a transverse axis that is horizontal, in which case the hyperbola opens out to the left and to the right. It can also have a vertical transverse axis, in which case the hyperbola opens upward and downward. Its center can be at the origin or at a point, HK. To begin, let us learn the standard form of equation of a hyperbola with C, 0, 0, and a horizontal transverse axis. A point P at xy is on the hyperbola if and only if x squared over a squared minus y squared over b squared is equal to 1. Recall, students, that a is equal to the distance from C to V. B is equal to the distance from C to B. To find the distance C from the center to F or F prime, we use C equals the square root of a squared plus b squared. By now, you should be comfortable using equations for conic sections. So let us try an activity. Please name the center, foci, and vertices for this hyperbola. Remember, students, that there are 2 sets of vertices. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Since there is no value given for h or k, we know that the center of the hyperbola is at 0, 0. According to the hyperbola equation, we can determine that a is equal to the square root of 36, which is 6. Since a is the distance from C to V, we find that the vertices at V are plus or minus 6, 0. B is equal to the square root of 81, which is 9. Therefore, the vertices at B, which are on the y-axis, are equal to 0 plus or minus 9. Finally, to find the location of the foci, we must use C equals the square root of a squared plus b squared. By substitution, this gives us C equals the square root of 117. This can be reduced to 3 times the root of 13. Therefore, the foci are at plus or minus 3 times the root of 13, 0. Similar to the other conic sections we have studied, a horizontal hyperbola with a center at HK rather than 0, 0, and whose axis is parallel to the x-axis has this equation. X minus h squared over a squared minus y minus k squared over b squared equals 1. C translates from 0, 0 to hk. The location of V becomes plus or minus a plus hk. F becomes plus or minus c plus hk. The location of B changes to h plus or minus b plus k. The eccentricity is c over a. The lengths of the transverse and conjugate axes are 2a and 2b respectively. And the length of the latus rectum is 2b squared over a. As you might expect, students, the equation of a hyperbola with a center at hk and a vertical axis takes this form. The positions of x and y are reversed. Students, we have time for one more activity. Please name the center, foci, and vertices for this hyperbola.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. Please compare your answers to these. C is found at 2, 3. A and B both equal 5. Since this hyperbola has a vertical axis, this means that the vertices at V and V prime will be 2, 8 and 2, negative 2. The vertices at B and B prime will be 7, 3, and negative 3, 3. To find the foci, we solve for C. C equals the square root of 50, or 5 times the root of 2. The foci are at 2, 3 plus or minus 5 times the root of 2. The foci are at 2, 3 plus or minus 5 times the root of 2. Were these your answers, students? Today, we learned the definition and properties of a hyperbola. We also learned the equation of a hyperbola. In our next lesson, we will review all possible standard form equations of hyperbolas, and we will discuss asymptotes. Until then, thank you, teacher. Thank you, students.